Okay, this is our first stop, GPS 45.75798 minus 87.94263. We're here to talk about the rocks here. But first, across the river there is Wisconsin. We're on the Upper Peninsula of Michigan here. I took you guys through the town of Niagara before. Niagara is west that way. And a lot of these cliffs are formed by igneous, I'm not sure if they're intrusions or extrusions. I'm pretty sure they're intrusions. But we're going to talk about what we're standing on here. I'm going to show you the map here a little bit. We are right here about right now. That's about where parking is. We're not that far from it. You can see this is the Menominee River. There's the town of Niagara. And here is that Niagara Fault. See it? And here I put the trends. As you can see, it trends mostly west, northwest, supposedly. And like I've said before, I don't doubt this fault exists. I'm just not sure its context. We have a serious doubt that this is some sort of large suture now. At least that's coming into question. Here it is in cross-section, the area. There's no vertical exaggeration. Parking went right through the cross-section, B to B prime. That's where parking was. So this is about that segment, B to B prime. So this is north. See, no vertical exaggeration. Parking is right about here. You can see we're in this green stuff. This is supposedly the Quinnipiac Formation. Here it looks different than it does in the rest of Wisconsin. We're going to talk a little bit about that here in a little bit. So right here we are south of where the Niagara Fault is mapped. That map I showed you was 1993 map done by Sims and Schultz of the Iron Mountain and part of the Escanaba Quadrangles. But the rocks here, you see these, you see the rocks here, right here, you see this, looks like a trend, a fabric, if you will, in the rocks. And that's what this is. There is a definite trend here. Now on that map I showed you, about right here, the Niagara Fault should be about north 65 west. These right here, trend is about north 85 west, or almost east-west. East-west trends are typical of the Penochian orogeny, so this is likely associated with that. But it's kind of odd that it's 20 degrees off from where they've locally mapped the Niagara Fault. And like I said, it's not exposed anywhere. So what we're going to do a little bit, I want to talk about the lithology of the rocks. Here that isn't a real good place to do it. There's better exposure not that far from here where I want to take you, and we'll talk about that too. Before we move out, you can see this quartz vein right here that goes this way. It's a good 2 inches, 2.5 inches thick. It does trend more of that north 65 west. It's actually north 70 west here. Whether that's significant or not, I don't really know. Okay, we are GPS 45.75810 minus 87.94318. But I want to show you here real quick, this stuff is not in place. Some of it's close, but most of it isn't. This is going to be a quick lecture about how you have to be careful what you're measuring. Could I take my blunt and compass and start measuring all these planar surfaces? Sure, I could, but why? See this big tree here? You can see clearly it has grown into and split this rock. We'll talk about the lithology in a minute, but split this rock along what appears to be a bedding plane, but at least along some sort of fabric, maybe some slaty cleavage. And then here you see this tree has pushed the stuff more level looking. This stuff looks more vertical. The rock here is nearly vertical in depth. So even this has been pushed by trees. And you come over here and you see this tree has messed with the orientation of the rock. And that's prevalent all through here. The closest stuff to in place is probably this stuff right here. But I'm also iffy about it, so I'm not going to measure it either. The stuff down at the river is in place for the most part. The stuff right behind Sarah is in place as well. So I'm going to cut down there and get a measurement on this. So right here, we'll see it. And to test if it's in place is you take measurements from stuff you know is in place, unquestionably, like the stuff at the river. And then if that trend, as long as you haven't wandered too far, because remember, you've also got to keep in mind that things like faults and folds can appear along at the size of a human scale. So you got to be careful. But we have no reason to suspect any of that is right here. So we're going to take our strike. And these rocks are non-magnetic, so I don't need to worry about that. And here, I get about north 85 west, north 86 west. So east-west, like at our previous stop. Now our dip, this is how I see if it's, we have an inclinometer, I set it to 90 to see which way it's dipping, if it's near vertical. And then I do this. My inclinometer that way tells me I'm dipping north, in this case slightly northeast, but essentially north. And the dip there, whoops, flip it around. Sorry you can't see it, but a dip of about 79 degrees, or roughly east-west trending with a 79-80 degree dip to the north, which is typical for this rock. So this is in place. And by the way, just so you know, because I forgot to say it before, the river is to the south of us. That way is north. The river here is essentially flowing from west to east. GPS 45.75798 minus 87.94422. Just gonna stop right here for a little bit to talk about the lithology of the rock. You know, what is this rock? Now, you look at it here, some of it's in place, some of it isn't. I have a piece of the rock here in my hand that fell off, and you can see it's kind of greasy. It feels greasy, and the luster's kind of semi-metallic on it. See it right there, and it looks to be at least foliated, if not laminated. The rock is aphanitic, fine-grained. Question here, and it's not so easy to answer, is this rock, the protolith, the parent rock, the rock that this originally was a sedimentary or igneous. Now, here's the thing. Most of the quintisect formation is an assemblage of mafic intrusive rocks like basalts, peridotite, things like that. There are some known sedimentary units, even some stuff that looks almost like banded iron formation. But if it was deposited on the floor of an ocean as magma was coming up, it's not surprising that there'd be sediments in there. It tends to be blackish, dark gray in color. Here it's more greenish. It looks more platy. This rock looks to me to be a phyllite or a slate. I think the protolith of these rocks is sedimentary. And most of them here are. There's definitely some things that look like lavas, but there's other things that look like gray wackies. This isn't them. You know, more lithic rich sandstones that have been metamorphosed. This is definitely metamorphosed. We do see the primary cleavage here, which can be reflective of a larger structure, but it also seems to follow bedding or laminations depending on what this rock actually is. I have not done any petrographic analysis. I've only looked at this in hand lens. The finer grained a rock is, the harder it is to tell its mineralogy, its internal makeup. And this is very fine grained, but just my general experience, the parent rock is likely a mudstone of some sort, not igneous. It could be mixed with things like ash and stuff like that, but it does look more clastic sedimentary. So you have your primary fabric here, and I just found the secondary fabric. You come here, it's not in place, so I can't really rely on measuring it, but you look at the face of this rock and you see what looks like lines in it this way, and sometimes it'll fracture on it. That we would take a plunge reading of to get a secondary fabric. Whether or not it means anything isn't known because it's not really expressive. It could just be the way the rock starts to fracture and fall apart. But this primary cleavage is distinct. It means something. It's too big, too consistent not to mean anything. But let's go a little further on the trail. The sun's out now, and see if we can see a little more geology. Okay, we are at GPS 45.75819 minus 87.94498. Okay, I'm going to show you just this real quick. This rock is not in place, but it is local, and you can tell it's really not in place because we have a complete foreign rock from glacial stuff up here. But this rock is close. And you look at the rock here, and it looks gray. It's definitely crystal, and you can probably see it shimmering in the sunlight a little bit there. Now, the question is, this rock probably did come from right around here somewhere. There's a small hill there. It could be very well the source. Is if the protolith or parent rock, is this igneous or is it metasedimentary? Now, what we've seen so far indicates, and by looking at what I'm going to call slate, demonstrates that we have about a medium grade of metamorphism in this area. So the problem is when you take a, doesn't matter, sedimentary rock or even an igneous rock, and you start to metamorphose it, if it's low-grade metamorphism, the primary structures are generally retained. And they might be elongated, but they're there. But as you metamorphose it more, those primary structures become elusive in favor of secondary metamorphic structures. So you tend to lose things like bedding, and you can get recrystallization without melting in cases. So it becomes really hard to tell the protolith. My money is that this is igneous, and it probably is quintusec. But like I said, the quintusec varies here from where it does elsewhere in Wisconsin. It looks a lot more like what we see at Horse Race Rapids, which is assigned to a completely different formation because it's north of the Niagara Fault Zone. And that formation is the Michigami, which is predominantly sedimentary and is things like mudstones that have been metamorphosed into phyllites and slates. So that's one of the enigmas questioning this fault zone here. But let's keep going, see if we can find some more stuff. GPS 45.75739 minus 87.94594. Just going to stop here real quick just to talk about this a little bit. This outcrop is a natural in-place outcrop. However, these particular boulders have been moved a little bit through things like tree growth and stuff like that. So it's in place, but not perfectly in place. So I'm not going to take a measurement, but we're here to see, you see that the rock looks different. The rock doesn't have that slaty cleavage expressed in it here. And you look at this rock here, and it's, you know, it's not fine grained like a mudstone. There's coarser grains in it, sand-sized grains, and they are somewhat rounded, indicating that this is sedimentary, that this is not a volcanic unit, at least right here. This was likely deposited as a lithic sand or a muddy lithic sand, a gray wacky, as people have traditionally called it. And you can kind of see sedimentary structures in it. You can kind of see cross bedding. See, this would be bedding. Like I said, it's not perfectly in place. And then you have this cross bed, which peters out right there. So we do have different lithologies. And this stuff here, and you can see it's gray, but it's like a greenish gray. And this stuff here looks a lot to me like the stuff we see north of here by Crystal Falls at Horse Race Rapids. Okay, we are at GPS 45.75732 minus 87.94584. Here we are only maybe 50, 60 feet south of the last outcrop. And this stuff here, the protolith, is unquestionably sedimentary and likely a greywacke. How do I know? Well, you look at this, and this looks like a proto-quartzite. It's lighter and colored, and it has rounded looking grains in it that have been slightly recrystallized, but there's a smoking gun, if you will. This one right here has an actual clast in it, a pebble. This would have been carried down slope. You know, when I mean down slope, I'm talking 5 degrees. When this was deposited as a muddy sand, or it's just a sand. So I would call this a proto-quartzite. And its protolith, or its parent rock, is a lithic arenite, which arenites are a type of sandstone. You remember you have arenites and wackies. There is some mud in this, so I don't know really if it's closer to a wacky or an arenite. I haven't looked at it closely, but these pieces are arenites. I could say that about those. So as you can see, they form different looking weathering patterns. We have the blockiness that we had with the more phyllite or slate material, but it doesn't cleave and fall apart like that does. It holds its shape a lot better. There's definite fractures in this stuff that you don't see in that slate. And it's more rounded too. The trees don't mess with it as much. They do, just not as much. I'm going to take some measurements here. See, because like I said, it is in place, especially down there, I can tell it is. So I'm going to take some measurements from this area, and I think this is as far west as we're going to go. I hope you all have a good day. No? Alright. Yeah, we'll forget that part. Maybe I didn't. There's a... I guess I didn't. Alright. Well, I can't find the secondary... Oh, it's recording? Okay. I can't find the secondary... I thought I saw it here, but maybe I didn't. It's huge. Huge detached block. How tall do you think that is? On the right edge, the tall edge, it's got to be 6 or 7 feet. You think it might be 8? Well, I don't feel like crawling up there. We're going to go here to these rocks. That was definitely a gunshot.
Oh, God damn it.
Is this igneous? Oh, we put in front of my... Oh, crap. Let me redo that. Slaty cleavage. But as you metamorphose...
Sean.
The
Is it a bear or a pupper that slipped?
I think it's a doggo that slipped. Because remember,
That's an awfully...
bears have 5 toes. They walk on the soles of their feet like we do. Yeah, or it's some weird slippage somebody wearing sandals did. Wait, look, here's more. I think somebody slipped weird. Yeah, somebody here's in their bare feet. Look. Okay, that's it.